Hello everyone. Today we're looking at rectangles. Rectangles are going to be quadrilaterals that have 4 right angles. Rectangles are going to have all the same properties of the parallelograms as well as some additional properties. For instance, in a rectangle, all 4 angles are going to be right angles. Let us say that angle ABC, also known as angle B, will be congruent to angle C, angle D, and angle A. Furthermore, in a rectangle, diagonals are congruent, such that diagonal TR is congruent to diagonal US. And in fact, when we combine this with the property of parallelograms, where diagonals bisect each other, we end up with rectangles with an additional property such that each of these diagonal parts are congruent to each other and form 4 isosceles triangles. Isosceles triangles, if you recall, are triangles that have 2 of the same side. And if they have 2 of the same sides, that means their base angles must also be congruent. Things to keep in mind. All right, so we've got 6 problems here and 3 figures to work with. I'll be using them and then erasing them for ease of access. Number 1, if AE is 36 and CE is 2x minus 4, we want to find what x is. Parallelogram property, diagonals bisect each other. Therefore, 36 is equal to 2x minus 4. If we combine our like terms, we end up with 40 is equal to 2x, or x is equal to 20. Number 2. If BE is 6y plus 2 and CE is 4y plus 6, find y. So in a rectangle, our diagonals are congruent, and in a quadrilateral, our diagonals bisect each other, such that each of these parts are going to be congruent to each other. We can therefore set up the equation of 6y plus 2 is equal to 4y plus 6. Combine our like terms, 2y is equal to 4, or y equals 2. Number 3, if the measurement of BEA is equal to 62, find the measure of BAC. So in this case, as before, we have our diagonals that are congruent to each other, and they bisect each other, which means that this side is congruent to that side, making this an isosceles triangle. If that's an isosceles triangle, then our 2 base angles must be congruent to each other. We can therefore find that equation, or find that value, by taking our 180, the total number of degrees in a triangle, subtract from it the 62 that we know about, then divide by 2, because we're going to have the remaining measurements split evenly between the 2 other angles. So 180 minus 62 is 118. Divide that by 2, gives us an angle measurement of BAC of 59 degrees. Now we want a situation where AED is 12x and BEC is 10x plus 20. So 12x and then 10x plus 20. We can set them equal to each other because of vertical angles. They're both on opposite sides of this vertex, which makes them vertical angles. If you recall, that's a topic from late September, early October. So 12x is equal to 10x plus 20. Combine like terms, 2x is equal to 20, or x is equal to 10. But we want to find the measurement of AED. So we're going to plug that 10 into our 12x equation, such that we have 12 times 10 to give us a measurement of 120 degrees. If BD is equal to 8y minus 4, and AC is 7y plus 3, find BD. In a rectangle, our diagonals are congruent to each other. We can therefore set up our equation as 8y minus 4 is equal to 7y plus 3. Combine our like terms, y is equal to 7. If y equals 7, we can plug that into our original BD equation of 8 times 7 minus 4. 8 times 7 is 56. 56 minus 4 is 52. Last one. If the angle of DBC is 10x and ACB is 8x plus 10, we want to find the measure of ACB. The way we're going to do that, we have these two measurements. Those are essentially two base angles of this isosceles triangle. Therefore, we can set them equal to each other, such that 10x is equal to 8x plus 10. Combine like terms, 2x is equal to 10, or x equals 5. Plug that 5 back in for our ACB, and we get 8 times 5 plus 10. 8 times 5 is 40, plus 10 is 50. And those are our notes for rectangles.